Okay, this is gonna hopefully be the last video for this lesson, right? Before we move on to something else. So what we are going to look at is this application problem where we're talking about throwing a javelin. And if you don't know what a javelin is, that's that thing that looks like a spear that they use in track and field events. They don't usually, I don't know if they do javelins in high school track. They might. I guess I don't know. But anyway, you'll see it definitely in the Olympics, right? And in collegiate track and field, it's a pretty common thing. It's a very old event, goes back a long time, right? So when we talk about the height of a javelin and throwing, we're basically talking about trajectories. And as we know, when we throw things, they tend to go like this, and then they'll flatten out, and then they'll start to come down, right? And if we did that over a long enough period, right? If the ground wasn't here to like stop it, right? It would eventually kind of look something like this on that side, and it would do the same thing over here, right? And so it's a parabola, right? And they call that a parabolic parabolic trajectory, right? Is what they call it. That's the physics term for it. And a lot of people use that term like jokingly, talking about it. But that's what it is, and that means that its trajectory, the way it flies, is in the shape of a parabola. So when we have problems like this, the reason they're modeled with quadratics is because quadratics give you a parabola, right? And they're not perfectly modeled with that necessarily always, but they're close enough where they can use it to predict it, right? So we are going to erase my crude drawing here, and we are going to look at, well, actually, you know what? I should have left that, but that's okay. So it says that it's modeled by this. So let's think about what happens, right? So you got dude over here, right? And he's getting ready, and he's going to throw his javelin, right? And he throws his javelin, and it flies, right? And then it comes down and it hits the ground, right? So we'll just say about there, right? And they say how long is it in the air, right? And so the height, right? The total height of the javelin, right, is modeled by this thing. So depending at what time it's thrown, that will tell you the height of where it's at. So if you figured out what the time was after the guy released it, like right at this point, it would give you the highest point of the trajectory. Whereas if you do it over here, it's going to be a lower point. You do it over here, it's going to be a slightly lower point than it was over here, right? And so if they're asking you how long is it in the air, basically what they're also asking you is the time that it hits the ground, because it's not in the air any longer after it hits the ground. So the total amount of time that it is flying before it hits is what they're asking us. So that time is going to be one of our x-intercepts of this equation. And we know how to find x-intercepts now. We find them by solving the quadratic equation. So it's going to be my x-intercept or the root of this equation right here. And so that's kind of important to know. Otherwise, you might be clueless on like how we're going to do this. But we know this. We know how to do, right? So we're going to write this down: negative 16t squared. And that gives us kind of a weird look, right? We're not used to dealing with negatives here, but you know what? We're not going to freak out about it, and we're just going to kind of roll with it and see what happens. Okay, so my A is negative 16, and my C is 5. So we're going to go A times C, which is negative 16 times 5, and that gives me negative 80. And so I want two factors of negative 80 that are going to add up to give me 79. Well, this is an easy one, right? Because we know that if it's negative, we have a positive and a negative, right? Or a negative and a positive. It doesn't matter how you want to phrase it. Either way, they're opposite signs as each other. And that add up to 79. Well, hey, man, 80 and negative 1. So that's what we're going to use. So we're going to decompose this now into negative 16t squared. Let's rewrite this 79t as plus 80t minus t, right? 1t, and then plus 5. Okay? And so I am looking at this and I'm saying, okay, well, let's factor out 16 does go into 80, right? And then I know that because I just did it, right? I just figured this out right here. So we can pull a negative 16t out, and this is going to give me t minus 5, right? Minus because a negative times a negative gives me this positive. The 16 times 5 gives me the 80, and negative 16t times positive t gives me negative 16t squared, all right? So looking good so far. And then we're going to go minus, all right, 1, and then this is going to give me t. And I'm putting the 1 there because we're going to need that for the other set of parentheses, right? And then it's also going to give me t minus 5 because the negative times the negative gives you your positive right here. So we pull this guy out, pull the t minus 5 out of both of these. We factor that out. And then my leftovers, these crazy looking things. Oh, sorry, I circled the wrong thing. This and this, right? Not this other thing because I'm just not paying very close enough attention apparently. So these two are going to go in here, 16t minus 1. All right, and now we've got two equations that we're going to solve for, right? So let's do this first one. We've got t minus 5, so we got t minus 5 is equal to 0. If I add 5 to both sides, I get t equals 5. And now for this other one, in blue, we've got negative 16t minus 1 equals 0. If I move my 1 over, right, by adding it, you will have your negative 16t over here. And then if I divide both by negative 16, I get t is equal to negative 1/16. And so what we have to do now before we go and just start spouting numbers is we have to think about what we're talking about. Well, t stands for time. It even says that, where t is the time in seconds. If we're talking about time, a negative number is not going to work, right? That's just crazy. So this value right here, even though it is one of the roots, is not relevant to this problem right here. And so the one that we are looking for, our winner chicken dinner, is this one right here, this t equals 5, right? Because that makes sense. And so what does that mean? Well, it says time in seconds. So the answer to this is it is in the air 5 seconds, right? It is in the air for 5 seconds, right? Which, if you think about it, I mean, it may not seem like a long time, but throw something in the air sometime, and you'll notice that it's not in the air usually very long, right? Before it hits the ground, or you catch it, or somebody else catches it. So there's your answer. That's how we found it. You know, we had to do a little bit of thinking, but you know, a little thinking's good once in a while, right? So again, hope these are helpful to you, and happy solving, and we'll see you at the next one.